Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 8, Linear Equations in Disguise. Okay, so sometimes when we have a problem like this, it doesn't look like a linear equation. A linear equation looks like 3x plus 2 equals y or something like that. Okay. A linear equation is an equation where x is to the power of 1 or x is to the power of 0, creating a constant. Okay, so in this exercise, we are going to determine whether or not something is a linear equation by doing SADMEP, if you will, PEMDAS in reverse, SADMEP or SADMEG. And when we do that, if there's an equal sign and we are crossing it either direction, then we must do the inverse operation. Okay, so here we go. Now, when I'm talking about this is a fraction within a fraction, and this is a fraction, so I don't want any denominators. So in order for me to get this denominator out of here, we would multiply by the same thing. So if I multiply both sides by it, if I had 7x plus 2 over 3, these would cancel, and I'm left with 6 plus x. And then I would have 7x plus 2 over 3 over here as well, and it still looks like it's messy, but that's what we have to do. So I'm going to show it a little different way. So what I'm going to do is I'm just going to copy this, 7x plus 2/3. Now the reason we are doing this is because when you look at this and you follow SADMAP, you say subtract first, then add, then divide, then multiply. So you'd be adding and adding first because it comes before multiplication and division. And so you'd say, well, 6 plus x is, I can't do it. And 7x plus 2/3, well, I don't know what x is, so I can't add that. And then we have a division symbol. Well, let's consider these groups. This is a group, and this is a group in that parentheses. So that's when some people call this SADMEG, grouping. Okay, so we have to consider those as being groups. So I want to get rid of the denominator. And when I do that, I have to multiply both sides by that denominator. So I'm just going to show it as in parentheses, like so. So if I multiply the left side by 7x plus 2/3, this whole thing cancels, and this whole denominator cancels, and I am left with 6 plus x. Now, in the past, if you've done these problems, you're thinking, well, if I want to get rid of 3/8, then I multiply it by 8 over 3, and that'll give me 1. But I don't want to multiply the other side by 8 over 3 because then I'll have a fraction again. So we can just get rid of this denominator here, and that is considered something over 8. So if I multiply both sides by 8 now, and that's down here now, if I multiply both sides by 8, then 8 divided by 8 is 1, and I'm left with 8 times 6 plus x, and that must be in parentheses, by the way, equals, we still have this 3 over here, and then 7x plus 2 over 3. So all I did was multiply both sides by 7x plus 2 over 3, and both sides by 8 over 8, or just 8, I mean. So that will get rid of both denominators, and so now we don't have a fraction anymore, so now we can do what SADMAP says, subtract, add, divide, multiply, exponents, and then group. In this case, we have the distributive property because I can't add what's inside. So now I'm going to multiply 8 times 6, which is 48, and 8 times x, which is 8x. And that is going to equal 3 times 7x is 21x. 3 times 2/3, the 3's will cancel, leaving 2. If that confuses you, 3 times 2 is 6. 6 divided by 3 is 2. So now I have an 8x on the left and I have a 21x on the right. I want to get all of my x's on one side. So I can subtract 21x over to this side, but then I'd have a negative x. I don't want to do that. I like having a positive variable because at the end we would have to multiply by -1 and y add another step. So I am going to subtract 8x from both sides instead of the 21. I always move the smaller of the two over to the other side to keep it positive. 48 will stay here. 8x minus 8x is 0. 48 plus 0 is 48. 21x minus 8x is 13x. Bring down the plus 2. Okay, so now it's starting to look more like a linear function or a linear equation like I showed earlier. So now I'm going to solve for x. It says, can this equation be solved? So we're trying. So I'm going to subtract 2 from both sides. When I subtract 2 from 48, I get 46. And that goes away, and I'm ending up with 13x. To get x by itself, I divide by 13, and I get x equals 46 over 13. 13 will go into 39, and it won't go into 46. 13 is prime, so this will not reduce. Okay, next example. Can this equation be solved? Well, we have another fraction equal to another fraction. Okay. This time, I'm going to try something different. I can multiply both sides by the denominator here and both sides by the numerator here, but we can also cross multiply. When I have a fraction, like 1/8, that is called a ratio. And if I have another ratio over here and call it 2/16 and put an equal sign in between them, then if this is equal, then it's called a proportion. So if I take 1 times 16, I get 16. And if I take 8 times 2, I get 16. And that is a true statement. So these are proportional. So we've done those in the prior unit module. And so now we're going to continue that here. It just makes it easier. So if I take 7 times 8, so I'm cross multiplying. I'm multiplying 7 times 8 equals 1 times the quantity 3x plus 9. Okay, 7 times 8 is 56. 3x plus 9 times 1 is simply 3x plus 9. And finally, I just need to subtract 9 from both sides. 56 minus 9 is 47. 3x, 0. So I just have 3x. 7 plus 4 is 11. 3 won't go into 11, so 3 will not go into 47. So when I divide both sides by 3, I get 47/3 equals x. Okay, so there's our little trick there, cross multiplication. Okay, in example 5 here it says, in the diagram below, triangle ABC is similar to triangle A prime, B prime, C prime. Looking back on module 3, we all should know that two similar shapes have congruent corresponding angles and proportional corresponding sides, meaning angle A, the measure of angle A equals the measure of angle A prime, the measure of angle B equals the measure of angle B prime, and the measure of angle C equals the measure of angle C prime. And we can set up proportions of given values and unknown values to determine the ones we don't know. So we're told it is similar, so we can set up this proportion. So if I'm going to compare AB, so AB in the name is right here, that corresponds to the first two letters in the other, and that's how these namings work. A corresponds to A prime, B corresponds to B prime, and C corresponds to C prime. So if I choose AB as my numerator in a fraction, I'm doing a ratio, and I compare it to A prime, B prime, well, that's A prime, B prime, like this. And we're going to set up a proportion, so I'm going to say equals, and then I need AC. So AC is 2, and notice A is here and C is here, so A prime, C prime, first, last is what they correspond to. So there's my corresponding proportional setup. And now I'm going to fill in these values. AB is x plus 2. A prime B prime is 9.5 centimeters. I will just leave it 9.5 for now, and I'll bring in the unit of measurement when we're done. Equals AC is x plus 2. A prime C prime is 12. So now that I've got this set up, I can cross multiply. So I'm going to multiply 9.5 times x plus 2 and set that equal to these two being multiplied. So that's equal to 12 times x plus 2. And I just notice I have an error. A prime C prime, or AC is x plus 2, AB is x minus 2, so I need to change this. Okay, so that's wrong. So x minus 2 is AB. Okay, so that should be 12 times x minus 2. Okay, so now I'm going to distribute. So 9.5 times x is 9.5x plus 9.5 times 2 is 19 equals 12 times x is 12x. 12 times a negative 2 is negative 24. Again, I'm going to move the smaller x over to the other side. 9.5 is less than 12, so I'm going to subtract 9.5x from both sides to keep my x positive. These will cancel, and I will get 19 equals 2.5x minus 24. I'm going to continue this up here. So if I have 19 equals 2.5x minus 24, I'm just going to rewrite this because I ran out of room. I'm going to add 24 to both sides. And when I do that, I get 9 plus 4 is 13, and 2 plus 1 is 4, equals 2.5x. Then when I divide by 2.5, okay, I get a calculator out here, and I'm going to take 43 divided by 2.5, and I get 17.2. 17.2 equals x. Okay, it did not ask, but if I plug these back in now, I can now say AC is x plus 2. 17.2 plus 2 is 19.2 centimeters. And AB is x minus 2. So 17.2 minus 2 is 15.2. Okay. Now we're on to exercises. So now that you've seen a few examples, pause the video, see if you can do the exercise 1, and then unpause it and check. So I'm going to continue as if you've paused it. Here we go. I'm going to simply cross multiply, and I'm going to multiply 6 times 2x plus 1. And I'm going to set that equal to 9 times 1 minus x. I will then distribute. 6 times 2x is 12x. 6 times a positive 1 is a positive 6. And 9 times 1 is 9. And 9 times a negative x is negative 9x. I have x's on both sides. Negative 9 is less than 12, so I will add the smaller one over to the other side to keep it positive. 12 plus 9 is 21x plus 6 equals 9. Subtract 6 from both sides, and I get 21x equals 3. Divide both sides by 21, and I get x equals 1 over 7. Okay, now remember, we can always take our answer, plug it in, so this should be 2 over 7 plus 1 divided by 9 equals 1 minus 1 over 7 divided by 6. and those should come out to be an equal value. I'm not going to take time in this video to check, but you always should check your work. Okay, so here's example 2, or exercise 2, I should say. So if you have not done this, pause the video, come back and check it. And here we go. So again, we're going to cross multiply. 7 times 5 plus 2x equals 6 times 3x minus 1. Distribute. 7 times 5, 35. Positive times a positive, positive. 7 times 2, 14x. Equals 6 times 3x is 18x. Positive times a negative is negative. 6 times 1 is 6. Move the smaller x, which is 14, minus 14 from both sides. And I'm going to get 35 on the left, equal to 4x minus 6 on the right. Add 6 to both sides, and I get 41 equal to 4x. Divide by 4, divide by 4. 4's cancel, and I get x equals 41 over 4. 41 is prime, can't be reduced. That is my answer. Okay, pause the video, try number 3. Okay, here we go. So now I'm going to do number 3. So I'm going to multiply. I'm use green for this. 3 times x plus 9. We're cross multiplying. Equals. And then we're going to multiply this way. 12 times the quantity negative 2x minus 1/2. Watch your signs. And then we're going to distribute. So 3 times x. 3x. Positive times a positive 9. 3 times 9. 9 times 3. 27. Equals. Positive times a negative is negative. 12 times 2 is 24x. Positive times a negative is negative. 12 times a half. Half of 12 is 6. Negative 24 is less than 3. I'm going to move 24. Add 24x to both sides. And 3x plus 24x is 27x. Plus 27 equals, these cancel, negative 6. Subtract 27 from both sides, and I get 27x equals. 27x came down, these 27's canceled. Negative 6 minus 27 is negative 33. Divide by 27, both sides. These cancel, and therefore x equals negative 33 divided by 27. They're both factors of 3, and so therefore that reduces. 3 will go into 33 11 times, and 3 will go into 27 9 times. So that equals x. Okay, let's do it that way. X equals 11 ninths, negative 11 ninths. Okay, here's number 4. Okay, it's just repetition. We're just practicing. So I don't care which way you cross multiply. You can do 8 times this first. You can do 5 times this first. You can do this times 5, this time. As long as you're cross multiplying, top left, bottom right, top left, doesn't matter as long as you go diagonally across. So if I go this way, it'd be okay. And if I write 8 times 2x plus a quarter, and then equals, and I like to have my number first. It doesn't have to be, but I always do it that way. So I'm going to put the 5 first, and then put 3 minus 4x here. I could put a 5 over here, like right here, instead of here, and distribute this way. It's okay, but it's not something I usually put the number outside in front of the parentheses, but it doesn't matter. And then we're going to take and distribute. So a positive times a positive is positive. 8 times 2 is 16x. A positive times a positive is positive. 8 quarters is 2 equals 5 times 3, 15. And a positive times a negative is negative. 5 times 4 is 20x. Negative 20 is less than 16, so I'm going to add 20 to get it over to this side. And when I combine like terms, I get 36x plus 2. I shouldn't say combine like terms, I'm just adding. And bring down this 15, and negative 20 plus 20 is 0. Now I need to get x by itself, subtract 2 from both sides, and I get these to cancel, and I get 36x equals 15 minus 2, which is 13. Finally, I can divide x by 36, divide 13 by 36. This 36 cancels with that 36, and I am left with x equals 13 over 36. 13 is prime. It will not go into 36. I cannot simplify that.